Hello coding friends. So this is a video on the new series about JSI updates. Today I would like to go over host objects, which is a topic that actually was available right from the beginning, but I didn't cover it. So I thought it would be interesting just to kind of walk through the code and maybe present to you some more interesting structures you can use for your host objects. So there are some points I would like to cover. First of all, what is a host object? So a host object is basically a C++ native class. I'm not sure if you can also do host objects on Java or Swift or Objective-C or whatever. Basically, the host part means native, and object is just an object, right? So it just means exposing your native object into the JavaScript context. What are the benefits or the disadvantages of host objects? So host objects don't necessarily have any performance advantage. There might be some benefit in there if you do have a lot of native code that just calls itself. You might see some difference in there, but mostly the main advantage of host objects is that allow you to use the C++ semantics of classes and instances and encapsulation without having to expose a bunch of bindings to the JavaScript side of things, right? So you can just use your normal C++ code and just expose a certain binding, a certain function to the JavaScript side, and then internally, it just uses C++ code. Disadvantage is that you might have to implement your class in a certain way, right, in order to expose your functionality. So it's not a free-form object, right? Also, when you try to access this object from the JavaScript context, it's not a regular object. It's not like you can write anything to it. You cannot assign new properties on runtime, for example. You can assign some properties, but not anything, right? So there is some disadvantage to using the host object. There might also be some advantage regarding lazy initialization and not having to create every single JSI value until you want to read it. But that depends on your implementation and might not be necessary depending on what you want to do. So let's get started by just creating a host object. So I'm just on QuickSQLite, which is the playground that I use to do all the JSI code for now. And I am going to select, going to create a new C++ file. I'm just going to call this native storage. And I'm just going to create it. And here it is. So let me just open some of the code that I have in here to make sure that I'm doing the right thing. So like I said, host objects are just native objects. So we just basically need to declare a C++ class. So I'm just going to start by, let me just import the required dependencies. So I'm just going to import the JSI header files. And I think for now that's enough. There might be some mistakes. We'll go fixing them as we go coding the host object. So I am also going to mark this class as a JSI export. Not 100% sure if that's necessary or not, but for now, we'll just leave it like that. And we'll call it the native storage. Now, you need to inherit from the JSI, what is this? Host object, yes. Right, so whatever C++ class you want to expose to the JavaScript context needs to inherit from this host object. I am also going to, just going to use a namespace in here just to make things a little bit more ordered, and I'm going to declare a namespace JSI, which is just the Facebook JSI, just to make things a little bit easier on us. Now, what else do I need in here? So you need to override two important methods when you are dealing with host object: the set method and the get method, right? So the set method will allow you to set a property inside of your C++ code, and the get one will allow you to get some property, right? And that property can be just a regular JSI value, so to say, or you can also get a JSI function, for example, right? So you call it, you get your object and you will call your function inside of that object. So we'll just declare here the JSI value get. This gets the JSI runtime, the JavaScript runtime object. And you will also get a prop name ID, which is basically the function that you will try to access from the JavaScript context. And we can just leave it like that for now, I guess. Or give me 1 second, let me just check. Blah, 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 blah. Get runtime. Right. Yeah, let's see how far we get with that. So for now, we'll just implement the getter, and we will see how far we get. So now I'm going to implement my actual implementation. Again, I need my namespace. I'm also going to redeclare again here the Facebook JSI namespace just to make our code a little bit easier. And I am going to declare the JSI. What is this? Native storage and get. Okay, this is not what I wanted, so I just want the get that I declared before. So here I have my runtime, which is passed by reference. I also have my JSI prop name ID, which is also passed by reference. And I have my implementation. And for now, I'm just going to return an undefined and empty value. And let me think about this. Let's just print to see, or I mean, let's just try to compile it, see how far we get with that. Okay, so my build fails, prop name ID. Okay, so here I have a mistake, have that. I have a difference, wait, let me sync that for example, store. Coolio. So what are you? So give me 1 second. Let me just move my head to the correct place. To change. So first. Okay, now. Disk. Tilde complain now. Okay, great. So the app has compiled, which basically means our host object, which is here. Why am I missing the header file? Oh, okay, wait 1 second. I am missing the header file because Finder. So I'm just updating the header file that C++ created for me, because C++ or Xcode creates it with HPP extension, and in my pod spec, wait, let me show it to you. In my pod spec, I am not using the source files that has the HPP extension. I can just change this. This is fine. So now I'm just going to go inside my example folder inside iOS, and I'm going to do a pod install just for Xcode to correctly import my header in here. So let's see. Okay, here it is. Now let me try to recompile the app. Okay, now it fails because this is the incorrect header. Coolio, now it works. So now that we have our implementation, we can basically do something like, let me just check. So I am going to get, let's call it method name. And basically from this prop name ID, I am just going to get UTF-8 string. And here it gets kind of the funny part, right? So if my method name, for example, let's say, I'm just going to give it a funny name, foo, right? And I'm just going to say, I want you to call this foo, right? Or I want you to return the return of this foo. My class doesn't have any foo method right now, but I'm just going to declare one. So this needs to return a JSI value, foo, and you don't take any parameters. So now here I need to do the same. I'm just going to declare it, foo, and I'm going to return, what was this? JSI value of 42. Let's see, oops, sorry, this is program ID, method name, Coolio. So here's the tester app, and I am, before we move on, this is the method that I want to test somehow, right? So this is the declaration of my host object, but this host object is still not exposed to the JavaScript runtime, right? This is just the declaration, it's just compiling. I still need to somehow pass it to JavaScript so that you can call it afterwards. So what I'm going to do is I have this installer file which kind of installs all my normal, so to say, bindings that are not part of any host object. And here I'm just going to add it as a property. But so first I'm going to create this, and I'm going to say this is a shared native storage, and I'm going to call the std make shared native storage. 1 second, let me just check the notation to make sure I'm not doing anything too dumb. Where are you? Smart host object. One second. Object. Where are you? Okay. Yes. Okay. Make shared. Here's my object, and I just need to pass whatever parameters that I have. I also need to add in here. I'm going to include my native storage.h. Right. So this creates. Let's go over parts. This is going to create a native storage object, an instance of the class that I declared, and it's going to create a share pointer. Now, I haven't explored share pointers in any of the guides, but it has to do with how objects are managed or are collected in C++, right? So if I would create just a regular native storage object, right? So if I would do something like this, the moment this file runs or finishes running, right? The moment I set all my properties and I put them in the global context, this will get deallocated, right? This is just normal C++ semantics. By doing make shared, what I'm doing is I'm creating a share pointer, and the share pointer keeps track or automatically keeps track of the references to this object. So what I'm going to do afterwards is I'm going to say module set property on my runtime, my native storage, and I am going to pass my shared native storage object. And what this is going to do internally, oh sorry, I'm making one mistake. I still need to call JSI object create from host object. Okay, now. And I also need to pass the runtime. Okay, so now this is going to work. What this is going to do is going to take this object instance, which is a shared pointer, and it's going to create a host object from it. And because it's a shared pointer, this is going to increase the count, the reference count. So it means it won't get deallocated, right? So this is my instance. When I pass it to the create from host object function, this being a shared pointer will prevent any further deallocation, and I'm just putting it in my normal proxy object for quick SQLite. So let's try to run this, and it compiled successfully. So let's just test this. I am going to go into my app.tsx, and here when my so-called very simple application starts, I just want to do something like quick SQLite and native storage and foo, and I'm just going to do console log. So right now there are some errors because I haven't fixed the TypeScript types. And oh well, yeah. So wait, you don't see it because of my face, but or let's just do. So you can see when the application starts, I get 42, right? So basically, this is what's happening, right? So this is my native C++ object. When I call foo, my get binding is being called in here, and I'm just internally calling the function foo. So let's say I want to return actually a function that can be called. So then I can just use the very same stuff that I have used in my other C++ code. I don't know what this is, but we'll just take it for now. And I'm just going to say I wanted to create a host function. So this is actually where the laziness comes in. right? This function hasn't been created beforehand until it's being called, right? So here I would say as well, if my method name equals, I'm going to call this bar. So let me just adjust the code. I have a 0 count, blah, 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 blah. Okay, I am just going to return a JSI value of 84 or something like that. So let me just compile this again. Runtime, just change this. And now, if I go here and instead I'm going to call bar, I should be able to see 84, right? So this is how you create a basic host object. The other part of this equation is the setter method, right? So here I would have set blah 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 blah, you know, it's pretty much the same thing. Well, maybe not exactly the same thing, right? But it's a similar, you know, it's the counterpart, it's just a setter method. So let me just look how this is implemented. So, okay, I have const value, well, this is JSI value override. So here, once again, I can get my name of the property. And, you know, if I have some variable declared on this class, then I could just write it, right? So you just pretend I have, you know, my private variable, and I can just go and just interact with it. I don't know if I need to return anything. This is it. So then, you know, I would do something like value string, for example, right? So if this is a string, I would just do and give me the UTF-8 string, right? So I'm just kind of writing inside of my C++ class. So that's kind of the core idea of host objects. I don't need this. But that's basically the core idea of host objects, right? They allow you to interact with C++ code between JSI functions. This is one way of doing things. There's also the way that I have done it before, which is just declaring your host object functions or your host functions and just putting them inside of a normal object. Like I said, the difference is on this object that I created in here, this is a regular JavaScript object. So I don't need to do anything fancy to set any variable inside of it, for example. I don't need to implement this set method. I can just use it from the JavaScript context as a normal object. But the capture semantics, or you know, if you have a very complex set of C++ classes, then doing host objects might simplify your life a little bit, because you can see here I can just directly call any C++ code because I'm inside of the C++ world. So it kind of allows you to use the object-oriented abstraction. So that's the basic host object. And one thing that I just wanted to show you is kind of an abstraction on top of this, which is used by some of the other libraries, especially all the Margello libraries. They're really cool. They have a lot of infrastructure set up. So I thought it would be a good idea to show how to do this properly. So we're going to call this smart host object. Yes, I'm going to create it. And I am just going to show you. I'm just going to copy the code so this is not too long. So my smart host object is going to look like, where's my header file? Okay. Going to look like this. So let's go over by parts here. My namespace, some other namespaces to make things a little bit easier. And don't worry too much about this field definition. build pair. We'll go over it in a little bit. So here I have the same thing, right? So I have my class, which is a JSI export, which implements the host object protocol. I have constructor, which takes the JS call invoker, puts it in a weak JS call invoker wrapper. This is a destructor. This is fairly advanced stuff. I don't want to get too deep into it. We can talk about it later. And basically here you can see the get function is also implemented. There is this get property names, which is also useful for the JavaScript code. And then I have a vector of pairs of strings and this type definition, which is a name and a host function. And this is called the fields. And then I have a weak pointer for my weak JS call invoker. I think I'll do another video about weak pointers, shared pointers, and so on and so forth. But what's the interesting part about this is that this kind of allows us to generalize host object implementation. So here I'm just going to replace this with smart host object HPP. And here I'm just going to implement the methods that I had before. So build pair is going to create a tuple between the name and a host function, right? So I have my function and I have my prop name, which I'm going to get from the runtime, and I'm just going to create a host function from whatever I pass in there. And finally, I am just going to make a pair of the name and the value builder. The get property names is also going to iterate over these fields that I have in there, and then it's just going to return prop name ID with the property names. And finally, we have the get implementation, which again just gets the runtime and the prop name ID. Here we get the name, and we iterate through the fields until we find the name. We get the host function, and we call it with the runtime. Or this is just the get object. And if nothing is fine, then we return undefined. Great. So you can see that doing this kind of implementation, where is this? This is kind of messy, right? Because inside of here we have a bunch of if methods, right? And we're comparing strings, and the function definition is kind of inline. So as your host object gets larger, this will get more complicated, right? Like this if statement will keep growing and growing and growing. And that's pretty much not what you want to do, right? Like you want to keep things somewhat separated. So this smart host object allows you to do that, because you can just put your function definitions inside of this field array by calling the build pair method, and it will allow you to have a little bit more of a structure whenever you're using your host object classes. So to implement this, let me take a look for a good example. I'm going to change my definition of the native storage class, and instead of using the JSI host object directly, I need to use my smart host object. And here I'm going to replace this with smart host object. And what else do I have in here? I guess that's it. I do need, though, a constructor now. So I am going to declare this as an explicit native storage. And it doesn't take anything for now. I just need it to be there. And here I'm going to change my implementation a little bit. I am going to do my native storage, my constructor, which doesn't take anything for now. We can take a look later. Oh, I do need the call invoker. Okay, let's change this implementation a little bit, just because I don't need a call invoker for this example that I'm trying to show you. So I'm just going to get rid of it for now. And maybe in a later video, I do really want to talk about the call invoker, but for now it's not important. Okay. So I have my native storage, and let me just check. Do you build? Cool, you built. So now what I can do is I can just do this field, and I'm going to push back, right? Because the fields is a vector reference to all my host objects, and I can just do something like std make pair, and the pair that I'm trying to make is going to be a JSI prop name ID. It takes my runtime. Well, actually, I know this doesn't look very simple right now. Let me just create one other helper file. I'm just going to call this macros. Sure. Actually, I don't need the C++. I don't need an implementation. I just need the header file. And here I'm going to define a macro that I'm going to use afterwards, right? So I'm going to define this JSIF capture, blah, 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 blah. So basically I'm just declaring a host function in here, right? It's just a way for me to a little bit more easily declare a host function. And here I can just say I'm going to build a pair out of my name. This was bar, and I'm going to use my macro that I declared before. So what is this? Macros. Great. And this macro takes, first of all, the capture semantics of the host function. So I'm just going to say I want you to capture everything that's in here. And finally just declares the body of the function. And here I can just go JSI value 92 or something like that, right? It doesn't really matter. I just want to show to you. And I am missing something. Did I declare something wrong? Guess I need this. Build pair. Okay. Good. So now we should be able to see here 92. Great. So this is kind of the most simple smart host object implementation. But you can take this abstraction even further, right? So maybe in another video I will continue exploring this pattern. But basically the smart host object can not only take a reference to the JS call invoker, you can also pass some sort of worker thread inside of it. So whenever you need to do async work, you don't need to do any custom threading code or whatever. It's part of the host object, so you can just say do this chunk of work in a worker thread and not in the main React Native UI thread. But this is a more advanced pattern. For now, I just wanted to show you host objects and how can you use them to easily encapsulate your functionality. Thanks a lot for your time, and take care, and I'll see you in the next video.